These are my predictions for paper 3 OCR A-Level Chemistry A exam 2025. So paper 3 is all about applications and practical skills. So expect so many calculations in your exam and some of the practical skills, and apply your knowledge in a more practical way. So use data to predict the formula or a structure of unknown. So what are the most common topics in paper 3? First topic is enthalpy change. So it's very common in paper 3. Usually there is a calorimetry experiment either to calculate the enthalpy change for combustion or enthalpy of the solution. And of course, that will depend on what came in paper 1. So if you had enthalpy of combustion in paper 1, it's not going to be in paper 3 and vice versa. And enthalpy change of solution calculation is one of the most common ones. Remember the equation, you're going to apply the equation Q equals mc delta T, and then delta H equals Q in kilojoule over moles. Also, they apply the values that you get from enthalpy of solution or enthalpy of combustion within the Hesa's law and use the Hesa cycle to find the enthalpy change for a certain reaction. So please go over Hesa's cycle and because it's going to be quite important for your exam. Entropy and delta G calculation. So if it didn't feature in paper 1, it's most probably going to be in paper 3. They usually ask you to use data again because it's all about calculation to calculate missing information, for example, like the delta S or the entropy, standard entropy for a certain compound or a certain substance, or you could use the data from delta G and delta H to calculate the delta S. So try to go over this topic if it didn't actually feature in paper 1. A reaction rate and order calculation, it's quite common in paper 3, even when it comes in paper 1, because it's one of the main topics in paper 1, but it also can feature in paper 3. So the usually there is a reaction order determination and rate determining step. The type of question here is going to be a bit different from the one that comes in paper 1, because this is a constant question in paper 1. Usually they would ask you to use graphs to find the order of the reaction and explain why the order is zero order or first order and so on. Also, they remember that they can ask you about why the order of reaction is zero order in terms of a certain reactant. Usually when you have a reactant which is in large excess, it's going to be zero order because there is a very tiny change or negligible change in the concentration of that reactant. They might ask you how to modify your experiment to find the order of reaction in relation to that particular reactant. Then you would need to say that you need to use much smaller concentration of that particular reactant, or use the reaction in their normal molar ratio as the reaction proceed. They may ask you as well to predict the two-step mechanism with the slow step and the fast step. The type of question here is much easier and simpler than the one that comes in paper 1. Also, Arrhenius equation might come in the exam, so make sure you go over the Arrhenius equation. Atomic structure and bonding, this is one of the main topics that will always be in the exam. The type of question that comes here is usually explaining the difference in the boiling points or in the melting points, either due to the different types of bonds like covalent bonding or the giant covalent structures or ionic bonding or metallic bonding and so on, or due to the difference in the intermolecular forces, especially when we talk about the hydrogen bonds. So for example, explain the difference between primary, secondary, and tertiary amines when it comes to the melting points, how many hydrogen bonds are there. Also, the electronegativity will come in the exam. It might be mentioned in the exam as well. So make sure that you go over this. Qualitative analysis, it's not too common in paper 3. However, it's worth to go over the different reactions or the chemical test to identify cations and anions. So the test tube reaction that you need to go over are the group 2 metal tests, which are the use of sodium hydroxide and the sulfuric acid. This is for the magnesium and for barium. The ammonium ion, of course, when you warm with sodium hydroxide and then test the fumes with litmus paper. The halide ions with the use of silver nitrate, acidified silver nitrate, and then dissolve the precipitate that forms in ammonia, dilute ammonia, and then excess ammonia to differentiate between the chloride, bromide, and iodide. The carbonate ion test, which is the use of dilute hydrochloric acid, and then test the gas formed, which is carbon dioxide with lime water. Sulfate ion, but the use of acidified barium chloride test, and then aqua ion. So the aqua ion tests are quite common in paper 3. So please make sure that you go over these reactions. Basic calculations. So there are, as I said, there are a lot of calculations in paper 3. So most of the paper will be about calculation. So make sure you know how to apply the ideal gas law, because definitely you're going to use it in your exams. Isotopes and relative atomic mass calculation, either from the mass spectrometry or mass spectrum data, or just from the data they're going to provide you. The empirical formula and molecular formula. So you're going to use data from experiments to find molecular formula or empirical formula of a known compound. The acid base and redox titration calculation. This is one of the main questions in your exam. So you will have to calculate the amount of a certain substance, or you could be asked to calculate the content of a substance in a mixture. So this is very common in the exam. Also calculation of uncertainty and percentage yield. Topic 7 is a reversible reaction, Kc and Kp. It's quite common in paper 3. So you need to go over the different factors affecting the position of equilibrium with the ability to explain that based on data. So they're not going to ask you the question in a raw format, but they're going to provide you with data from experiment and ask you to explain whether this reaction is actually exothermic or endothermic. So it's more about application rather than asking you about the basic knowledge of the topic. Also, they could ask you to calculate the Kc or Kp from the data of the experiment. The pH, it's also quite common in paper 3. Usually there is a question where it's embedded within other questions where they ask you to calculate the pH. It's specifically for weak acids. So it's very common to ask you about weak acids, either to calculate the pH or to calculate the Ka of the weak acid. So it's worth to go over the different equations to calculate the pH. And these are all the equations that you will need as a knowledge for your exam. Acid-base pairs also quite common in paper 3, so they could ask you to write the acid-base pair and label each. So we are talking here about the pronested, Lowry acid and bases, how you can identify the acid and then the conjugate base that formed from the acid, and then the base and the conjugate base from that deconjugate acid from that base. And when you label them as A1 plus B2 will give you B2 plus B1 plus A2. So because this is the acid and this is the conjugate base for the first acid, and this is the second base, and this is the conjugate acid of that base. Shapes of molecules, one of the main topics in paper 3, and usually they ask you to predict the bond angle of certain compounds you've never seen before. Mostly there will be double bonds in these compounds. So just look at the electron areas or areas for electrons rather than just electron pairs. So you could have a double bond. So for example, if you have something like this where C double bond O and like that, so you have four pairs of electrons. However, you only have three areas of bonding. or three areas of electrons. So this is going to be a planar compound, trigonal planar, and the bond angle will be 120 degrees. So they're going to ask you in every single exam, there will be some compound that you've never seen before or you never practiced before actually, and they're going to ask you about to predict the bond angle. Also, they can ask about the ligand and transition metal complexes, their shape, and also the cis and trans isomers for these complexes. Electrode potential and redox reaction. Electrode potential itself is not that common, so if it doesn't feature in paper one, it will be in paper three. But if it has already been in paper one, it's quite unlikely that it will be in paper three. It's quite important to go to refresh yourself with the calculations for the EMF and how to calculate the standard electrode potential and also the redox calculations. At least there will be one redox equation in the exam. So redox is very common in paper three, and at least there will be one, if not more than one. They will ask you to write the half equation and the overall equation for a certain redox reaction. So make sure that you master these types of equations. Organic chemistry, the exam is not organic chemistry heavy. The functional group identification tests with the structure of the product is important because if it comes in the exam, although it's not that common in the test, but if it comes, they would normally ask you to draw the structure of the product from that particular test. Like if you have an acid and you use sodium carbonate, organic acid, and you use sodium carbonate, for example, that will give you the sodium salt of the acid and carbon dioxide and water. So you should be able to identify the different product from the different reactions. Analytical techniques like NMR. So usually the question is much simpler than what it comes in paper one. So they might ask you to identify the number of non-chemically equivalent carbons or hydrogen. They might give you some data to identify a structure, telling you that it gives you 3 signals or 4 signals in the NMR or in the carbon-13. They might ask you to explain the split patterns for certain hydrogens and a certain compound and so on. So just make sure that you know the basics at least. And IR as well, they might provide you with an IR for an unknown compound and ask you to identify the structure. Reaction mechanism, there will always be reaction mechanisms in the exam. Usually the reaction mechanism that come in the exam is not the typical reaction mechanism that you are used to, but it will be an unknown or quite a new reaction mechanism. They will guide you in the question and either ask you to draw the curly arrows from the different intermediates and the start and the product, or they're going to ask you to propose the mechanism from the instruction they're going to give you. So they're going to describe it in words, and all what you need to do is to draw the structure. So they're going to be unfamiliar mechanism. What you need to do is just to make sure that you identify your nucleophile and electrophile. You have to know the difference between nucleophiles and electrophiles, and you can propose the your proposed reaction type, and you can follow the rules for the curly arrows. So the rules for curly arrows is that the arrow goes from lone pair of electrons or from the electrons into from the nucleophile into the electrophile. So always use this rule for curly arrows. And then isomers, there's usually a question about isomers within other questions, like can you draw the two or propose like two cis isomers for the product or for a certain structure or a certain compound. So there will be something related to isomers as well. So if isomers featured heavily in paper one, then the expected questions about isomers in paper three would be a small question, like a question with 1 or 2 marks. But if it didn't feature in paper one that heavily, then probably in paper three there will be an extended question about isomers. So it depends on so in paper two, I'm sorry, because isomers in paper two. So it will depend on which one came in paper two. The practical skills then. So practical skills will be definitely in the exam because we said that paper three is all about practice, practical skills, and applications. So they're going to ask you to draw a diagram for a certain apparatus that you can use to do a certain experiment. And they're going to ask about purification, recrystallization, and making a standard solution. Not all of that will be in the same exam, but these are the practical skills that usually come in paper three. So what are the most important apparatus that you need to know and draw diagram for? These are the most important one, the one that are most common to come in the exam. The first one is the apparatus that you use to measure the volume or calculate record measurement of mass and volume of a gas. So this is, you need to know how to draw this one. You could also use a gas syringe instead of using this inverted tube. Drawing a diagram for an apparatus that is used for reflux, it's very common, came so many times, so you need to know the way of the water, how the water goes in and goes out, goes in from the bottom, goes out from the top. Don't forget the heat and the round bottom flask at the bottom there. And then using distillation as well. So you have to draw the thermometer, you have to draw your Liebig condenser. Liebig condenser, of course, the water will go in from the bottom, go out from the top. Again, the heat, and then the receiving flask. And finally, use an appropriate apparatus to record measurement of mass to determine empirical formula. So if they ask you about that, so